Today, we're going to make a shader with rain dripping down the screen in Unity and Unreal. Let's go! So if we take a closer look at this effect, there are two separate things happening. First, we have animated rain drops that are staying in place, and second, we have rain drips that are running down the screen. In last week's video, I showed you how to set up the first effect to make the drops that are staying in place. If you haven't seen that video, be sure to go back and watch it so you'll know how to get started. I'll link it here and in the description. So today, we're going to focus on these drips running down the screen. I'll show you how to set up this shader in Unity, and then we'll switch over to Unreal and take a look at it there as well. So let's go ahead and get started in Unity. The first thing that I'm going to do is right-click and pick Create, Shader Graph, Subgraph. And we're going to call our new subgraph Rain Drips on the Lens. Alright, so here we are in our new subgraph, and we need to go ahead and add some textures to our subgraph. We need to add rain drips, and we also need to add our rain drip mask. Let's take a closer look at these textures just so you'll know what data we're getting from these. So here is our rain drips texture. And what I've done in this texture is in the red and the green channels, I've encoded our normals, and I just have these kind of bumpy looking channels that the drops are following. So this is the left and right data for the normal, the X data, and this is the top and bottom data for the normal, the Y data. Then in the blue channel, you can see I have this mask that masks out the channel that the drops or that the drips are going to be following. And in the alpha channel, I have these drip channels divided into swim lanes, let's call them. And you can see that each of these lanes has a different color. And what this is it's a temporal offset mask so that each of our drips coming down can go at a different time and at a different speed. So I'll show you how we're going to use each of these channels in just a minute, but I wanted to show you the whole texture overall so that you can see how this is going to work. And then for our second texture, we have our rain drip mask, which you can see is just 4 pixels wide by 512. And this mask determines the shape of the drip. You can see that there's kind of a concentrated drop here at the end, and then there's a gradient that falls off. Now don't worry if you don't know exactly how to create these textures. I've already created them, and I'm going to link them in the description so you can download them from my website. Okay, well let's go ahead and start building our subgraph here that uses these two textures. So the first thing that we need to do is something that's exactly like what we did last week, and so I'm just going to copy and paste it. What we're doing here is we take the width and height data, that is how many pixels across and down our screen is, and then we divide the width by the height to get our aspect ratio, and then we combine this with a value of 1. And then we take our screen position and we multiply it by our aspect ratio. And the reason that we're doing this is because we want our texture to have square UV coordinates. We want our UV coordinates to be square. Whereas if you look at my screen here, it's got a 16:9 aspect ratio. And so if I just use screen position, I have a lot more pixels across than I have pixels down. So what this little unit of shader nodes is doing is, I don't want to call it normalizing, but it's making a stretched aspect ratio of UV coordinates into a square so that we can use them correctly. All right, the next thing that I want to do is just add a multiply here. And we're going to multiply our values by 0.7. And this is just going to scale our UV coordinates. Now that they're square from this bit of code, we're going to scale them by 0.7 just to get the right size for our drips. And this is a value that you can tune to your taste. If you want to make it higher than 1, you can make thinner, smaller drips, or you can make it lower to make larger, fatter drips. All right, and then these are the UV coordinates that we're going to use to look up our drip texture. Actually, I'm just going to maximize the window so we can zoom in here and make these nodes as large as possible so everybody can see. Okay, so the next thing that we need to do is take the data that's coming out of our drip texture sample and process it just a little bit. So I'm going to take the RGBA out here, and I'm going to add a swizzle node. And I'm just using this swizzle node to mask out the X and the Y because that's our normal data. And our texture is stored. Actually, you know what? Let me show you this just really quickly. If we switch to our rain drips texture, you can see that I've unchecked sRGB, so this data is being stored as linear instead of sRGB. And then down here at the bottom for format, I've set it to RGBA 32-bit, which means it's uncompressed. Now that's important because texture compression can really destroy this data. So I've made the texture just 512 by 512 and uncompressed. And this is about the same amount of memory as a compressed version would be if it were 1024 by 1024. So keeping this texture small allows us to store it uncompressed and get fairly high quality data out of it. Okay, so let's go back to what I was doing before. So we're not storing this as a normal map because it has those that temporal data and that mask stored along with it. And so because it's not set to be a normal map, we need to do the normal unpacking ourselves, which means we need to add a multiply. And we need to add an add. And so normally when you unpack normal data, you multiply by 2 and you subtract 1. But in this case, I'm going to be multiplying by 6 and subtracting 3. And the reason that I'm doing this is I want my normals to be just a little bit stronger to kind of accentuate them. You can see in this thumbnail here that because I'm multiplying by 6 instead of 2, it's really cranking up my contrast here and making my normals stronger. All right, so let's go ahead and minimize these guys. So multiply by 6 and subtract 3. And we'll move these over just to make some room. And so I've got my normal data coming out now, but I need to create an animated mask. So these are my normals coming out, but I need to multiply them by an animated mask coming down. So let's create that next. So I'm going to take the blue channel of my texture here, and I'm just going to create a round node so that I can get nice straight channels here. Well, not straight, but the round node makes it so I only get black and only white. That gives me nice sharp edges on the edges of my channel. Okay, we're going to set that aside and come back to it in a minute. And the next thing that I need to do is set up my animation. So the first thing that I'm going to do here with the animation is add a lerp node. And the data coming out of my alpha channel of my texture is going to determine the speed of my drips. So depending on what this what each of these channels look like, I'm going to lerp between negative 0.25 and negative 0.1. So this is going to give me the speed and direction of my channels. And then we're going to add a time node so that we can create animation. And I'm going to take this alpha channel here and we're going to add it to time. So here's my time coming in. And we're going to add time to that alpha channel data. And then we're going to multiply this lerp and this add together. And that is going to give me my channels. Now, we don't see anything here in this preview because my data is negative. So at this point, we're just about ready to start sampling our drip mask here. But we do need to take the UVs that we created over here. And we're going to scale them just a little bit. So I'm going to come up here and add a multiply. And I'm going to multiply the X by 2 and the Y by negative 0.5. And that will invert my Y. And then we're going to take this value here and add it together with the time value that we've created down here. So this is controlling the channel speed, and then this is controlling the size of the UVs. And if we add this together, and then we use this as our UV coordinates for our mask, now you can see that those channels and the mask together have turned into these individual channels here that are flowing, each of them at a different speed and a different offset. So then we can take the red channel here and multiply it by our channel mask, which is what we're getting here coming out of our blue channel. And if we plug these together, now you can see I have these really nice masked off drips that are coming down the screen. And this is the effect that we're looking for. So this is going to give us the speed and the placement of the drips. And then here we have the normal of the drips. So I need to multiply the normal of the drips by this mask, which is going to give us the animated normal of the drips coming down the screen. And that's exactly what we're looking for. So we've created the effect that we were going for. So now I'm just going to clean up the graph, just kind of minimize these previews and kind of compact things together so that it doesn't take up as much space. So the whole graph is a little bit easier to read and to deal with. And as soon as we get everything organized, then I need to create my outputs. So now I'm going to open up my graph inspector. And my normal in this case is just an X and a Y. And so I need to set it to be a vector 2. And we'll call this normal. And just in case I need it later, I'm also going to add a second value for my drip mask. And we're just going to wire the mask itself out. And so I'll have two outputs for my shader. I'll have my normal data as well as the mask data. Now remember, the mask data is just black and white and it looks like this. And the normal data is green and red and looks like this. This is what's going to create the warping that we see on the screen. Okay, well, our subgraph is all done. There is one more thing that I can do, actually. I'm going to open up the Blackboard here and add an input parameter. And I'm just going to call this rain. And I'm going to give it a default value of 1 over here in the graph inspector. This is a value that's an input for my subgraph. And I can use it to tell the subgraph if it's raining or not. So if I bring this in and I multiply my mask by whether or not it's raining, that will just give me a really easy on-off switch that I can use to turn the mask on and off. All right, so we're all done with the subgraph portion of our shader, and now we just need to use it. So let's switch over to the full screen shader that we created last week. And here's that shader. So we have raindrops on the lens. This is the subgraph that we created last week. We're multiplying that normal by 0.03 just to tone it down. And then we're adding the screen position to that, which is our texture coordinates. Then we're using those modified texture coordinates to sample our full screen result. And so that gives us a shader that looks like this. You can see that it only has the drops and it doesn't have the drips yet. So let's go ahead and add our rain drips on the lens subgraph to this shader. And all we need to do is add this effect, which is the drops, together with our drips. So there's our drips and our drops added together, and we'll wire that into our multiply. And then save it. And when we switch back to our scene, now you can see that we're getting our rain drops that are staying in place, and we're getting our rain drips that are dripping down the camera. If I only want to do the drips, I could skip this add node here and just wire the drips directly in and save that. And now in our scene, you can see this is the part that we created today with just the drips dripping down the screen. This looks pretty cool, but I think that the two effects look best when they're together. So we'll wire the add back in and save it and switch back to our scene. Now we have animated drops and animated drips together, and it looks pretty amazing. All right, cool. Well, hopefully that all made sense. If you have questions about how this is set up, feel free to post them down in the comments. And in the meantime, let's switch over to Unreal, and I'll show you how to do the same thing there. All right, so here we are in Unreal, and just like we did in Unity, we have our post-processing effect shader here with our animated rain drops that are staying in place, and also with our animated rain drips that are running down the screen. And the way that we're doing this is with a global post-process volume, and in the settings for the global post-process volume, you can see that here we have post-process materials, and there's an array, and inside that array, I have one element with this shader called test post-process rain on the lens. So let's take a quick look at that shader to see how it's set up. So I have weather screen drops, which I showed you how to make last week. And then we have weather screen drips. And this is the one that we're going to take a look at this week. So those effects, the normals coming out of both of those are added together and then multiplied by 0.03 just to tone down the normals a little bit. Then our texture coordinate node is actually the texture coordinates for the screen, and those are getting added to the normals. And so the normals are distorting our texture coordinates. Then we use those texture coordinates to look up into the screen buffer and distort what's on the screen and then apply it back. So let's go ahead and make a brand new weather screen drips material function, and I'll show you how this is put together. So we'll open up our content drawer and scroll down to the bottom, and I'll right click and go to materials and create a new material function. And we're going to call this one weather screen drips. We'll open up our brand new material function here that's completely empty. Our result is just called result right now, and we're going to rename this to normal. And then we're going to create a new one. So we'll search for output. And we're going to grab a function output. And this is going to be our mask. Now for sort priority, I'm going to give this one a 1 because I want it to show up second. Okay, the next thing that we need to do is add our textures. So I'm going to add our drip texture here and add our drip mask here. All right, now we need the texture coordinates for our drip texture. And so I already showed you how to do this last week, so I'm just going to copy and paste it in. But this is the method that we use for making the UV coordinates for our texture square. We have a square texture here, but our screen is not square. It's a 16:9 aspect ratio. And so what we need to do is figure out what the aspect ratio of the screen is by taking the X dimension and the Y dimension and dividing them. Then we'll append a 1 and multiply by our screen coordinates. This is going to give us square texture coordinates. And we've already gone over this in a previous video, so I'm not going into a ton of detail, but I just wanted to make sure that you understood that. The next thing that we need to do is multiply these texture coordinates by 0.07 just to get the proper scale for our drips. Then we'll wire that value into our drip texture. Okay, I already showed you in the Unity portion of the video what this texture contains. But just to go over it again quickly, the red and the green channels are the X and the Y of the normal. The blue channel is the channel mask, or it's black where the drips are not, and white where the drips are. And then the alpha channel is like the swim lanes, and each of the swim lanes gets its own gray value, which we're going to use for temporal offset. So let's go ahead and deal with the normals portion first. I'm going to take the RGB output here, and we'll add a component mask where we just need the red and the green. This is our normals data. And in order to unpack it, I'm going to multiply it by 6 and subtract 3. So we're going to add an add node, and I'm going to add a -3. So multiplying by 6 and subtracting 3. Again, normally when we do this, it's multiplying by 2 and subtracting 1. So we get a range of -1 to 1. But in this case, I'm doing 6 and 3 because I want to increase the contrast and make my normals a little bit stronger. Okay, so that's going to give me the normals that I want, but now I need to create the animation of them streaking down the screen. So here are my normals, but you can see they're not animated yet, so I need to create the animated mask. So the next thing that I'm going to do is I'm going to take my blue channel and add a round node to it. And then I'm going to multiply this round node by my animated mask, which I don't have yet. So I'm just going to leave the B open there. And then this is going to be what we end up masking our drips by. So there's our multiply, and this will give us our final result. But again, we don't have our animated mask yet. So that's what we're going to create now. So in order to make the animated mask, we need to create a lerp node. And we'll plug the alpha channel of our drip texture into the alpha of the lerp. And we're going to be lerping between a value of 0.25 and 0.1. These values control the minimum and the maximum speed that our drips are going to be going. And if you want your drips to be going slower or faster down the screen, you can adjust these values here. The next thing that we need to do is add a time node. And we're going to take the alpha channel again here and add time to it So we're using this alpha channel as our temporal offset. So we have our lerp and we have our time, and we're going to multiply these together to get our final speeds. And this is going to give us the animated swim lanes that our drips will travel through. So we need to take these time animated values here and add them to the UV coordinates that we've already generated in this portion of our graph. So here are our square UV coordinates. I'm just going to take this value, and we need to adjust these UV coordinates a little bit so that we can scale the drips to the right size. So I'm going to hold down the 2 key and click, and that's going to give me a vector 2 value. So I'm going to set the X to 2, and I'm going to set the Y to negative 0.5. And these will scale our UV coordinates for our swim lanes. So I'm going to take this value here, this scale, and we're going to add these UV coordinates together with our time. And then we're going to use that as our UV coordinates to look up into our drip mask here. So if we preview what we're getting from our drip mask, now you can see that each of my swim lanes is slightly offset from the rest of them and moving at a slightly different speed. So that's what we're getting from this temporal offset alpha channel coming out of our drip texture, controlling the speed here with our lerp, and then adding to our UV coordinates there. And now all we need to do is take the red channel coming out of here and multiply it together with the mask that we created. Actually, I already have this multiply, so I can just take this red channel and wire it in right there. So if we preview this now you can see that I have a really nice mask in the red channel of my drips dripping down the screen. So now we can take this mask that we've got here and multiply our normal map with it so that we only get these drops or these drips in the places where our mask is showing. So this is our mask. These are our normals, and we'll wire the normals coming out of there and going into our output normal. And this is our mask. We'll wire that coming out of there and going into our output mask. Okay, now I'm just going to kind of minimize things and clean up my graph a bit so that it'll be a little bit more clear if I need to come in here next time and see what's going on. Just going to give myself maybe a little bit more space and move these things out. Okay, cool. That is my whole material function. I have my UVs at the beginning. I'm multiplying by 0.7 to scale the size of the drips. And here I'm multiplying my UVs by 2 and negative 0.5 to scale the size of, or the dimensions of the lanes that the drips are fitting into. And then I'm rounding my mask to give it a nice sharp edge. And then I'm multiplying these swim lanes to get my final drip mask here. Then I'm multiplying my final drip mask together with my normal data to get my final normals. And I've got my drips coming down the screen. And now I just need to use these drips to offset the screen texture coordinates, which is going to create that final amount of distortion to the screen. So I'm going to go ahead and save this. We'll switch back to our post-process shader. And this is the drip material function that I created as reference. But I can replace that one now to the ones that we just built together. And I'll wire that one in instead and delete the reference one We'll save it and switch back to the final scene. Now you can see I have my nice drips coming down the screen. If I want to isolate it and only take a look at the drips, I can skip this add node here and just wire the drips directly in. We'll save that and take a look. So now this is what it looks like if there are only drips coming down. But you can see in my shader I have my drops that we created last week, my drips, and we want to add those together to get both effects at the same time. And now we have our drips and our drops. So pretty cool. This is how you create rain on your lens, or if you're creating a driving game, you know, this is how you create rain on the windshield. Anyway, I hope this was all clear. If you have questions or you're wondering how something is working or if something is not working, post a comment down below and I'll do my best to help you out. Hope you enjoyed the video today. If you have ideas on post-processing effects that you'd like to see next, let me know in the comments and we'll go over those in future videos. Have a great week, everybody, and come back next week ready for more shader post-processing goodness.